Hello everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, I want to discuss about some of the problems by using Stokes theorem and how to verify the Stokes theorem also. So, in the previous video, what is the Stokes theorem and how to verify the Stokes theorem we discussed. So, in this video, we are going to discuss some more problems based on the Stokes theorem. So, first of all, what is the Stokes theorem statement? The Stokes theorem states that the surface integral of the curve of a function or the surface bounded by a closed surface is equal to the line integral of the particular vector function around the surface. So, here we are taking integral over C, f dot dr is equal to double integral over S curl f dot n ds. So, here this is the statement of the Stokes theorem. So, this is the thing we have to know and we should prove if they are asking in the problem to verify the Stokes theorem. So, here I want to tell you about what is C. C is a closed curve and S is bounded by C and F is a vector field whose components have the continuous derivatives in the open region of R cube containing S. So here two types of problems are there here in the Stokes theorem. So one is using Stokes theorem. So using Stokes theorem means here in the statement, so LHS part and RHS part is there. We can calculate LHS or RHS. So either one we can calculate if they are asking to calculate using the Stokes theorem. So here what is the advantage of the Stokes theorem is, so in the line integral to calculate the integral f dot dr bar along the curve is too difficult. That means it's too lengthy. So when you are taking the curl of that function, if you are doing over the surface, then it will be easy for us and we can calculate within the stipulated time. So for the line integral to calculate along the path, so it takes so much time. So compared to surface integral. So that's why it is useful to us to save our time and to calculate the given value easily. So in the second type of problem, they can ask verify Stokes theorem. So verify Stokes theorem means here we have to calculate LHS part and RHS part. So that is the difference here. Using means either one, you can calculate LHS or RHS. If they are asking verify Stokes theorem means you have to calculate LHS and RHS both values. So we have to show that these two are equal based on the statement. This type of problems are we discussed some of the problems already. So we are going to discuss some more now. So see the problem. Calculate the curve line integral over C f bar dot dr bar where f of x comma y comma z equal to minus y square I plus xj plus z square k. So what is the vector field here? They given f equal to minus y square I plus xj plus z square k and C are curves consisting of the plane. So y plus z equal to 2. Here one plane is there, that is y plus z equal to 2 and the cylinder also is there, that cylinder is x square plus y square equal to 1. That is the cylinder and one more plane they given, that is y plus z equal to 2. These two we are having to calculate about the limits for the function to integrate along the path or the surface integral. Here we can see that, you can see the figure here. Here C is an ellipse. C is an ellipse. Here we can observe that this is in the shape of ellipse. This is in the shape of ellipse. Now to calculate along this path and we will use this one. What we are going to use here? We are going to use the Stokes theorem. Actually in the problem they didn't mention about Stokes theorem. Some of the problems they are giving using Stokes theorem. Using Stokes theorem. calculate the curve. Otherwise, verify the Stokes theorem, calculate the curve. If they didn't mention any value, just they are asking to calculate the curve for the line integral, means we can calculate by using the line integral formula also. Otherwise, we can use the Stokes theorem also to calculate easily. So that's why here I am going to use the Stokes theorem to solve this line integral. So what is the statement of the Stokes theorem? Integral over C f bar dot dr bar is equal to double integral over S curl f dot n ds. Curl f dot n ds. This is the statement of the Stokes theorem. So what they are asking? They are asking to calculate integral over C f bar dot dr bar. F bar dot dr bar. That means if we calculate the double integral over S curl f dot n ds also, that is equal to integral over S f bar dot dr bar according to the statement of the Stokes theorem. So that's why I am going to calculate curl f now. So you can see here curl f bar. First of all, what is the given f? Given f bar equal to minus y square I plus xj plus z square k. This is the given f. So I am going to calculate curl f. So ijk dou by dou x, dou by dou y. Already we know about the del cross f. So what is the del? Del is I dou by dou x plus j dou by dou y plus k dou by dou z. So now I am doing the cross product here. That is del cross f is nothing but curl f. Del cross is nothing but curl f. So del cross f curl f equal to, first we are taking ijk dou by dou x, dou by dou y and dou by dou z. Here first coefficient I coefficient for the f is y square and j coefficient is x and k coefficient is z square. So I dou by dou x, dou by dou y, dou by dou z, and here y square x z square. Now we are going to calculate the cross product here. So this one I into when you are taking I here, so we have to do the cross product for the these values. That is dou by dou y of z square minus dou by dou z of x. This is the first term. Next, minus j into, when you are doing for the j, we are taking here these two. So dou by dou x of z square minus dou by dou z of minus y square. This is the second term. Next, third term. So k. So when you are taking k here, we will do the cross product for these two. So here dou by dou x of x minus dou by dou y of minus y square. This is the value. So when you are calculating this value, here we can observe I into dou by dou y of z square, that is 0. That is 0. Minus here dou by dou z of x, that means we are doing with respect to z for the x. So this is the constant, this is also 0. So first term is 0. First term value is 0. Next, minus j into here dou by dou x of z square. So when you already we know about the partial differentiation, right? So when you are doing with respect to x, so z is treated as constant. Only z is there, so that is 0. Minus here dou by dou z of minus y square. That means this is also 0. So first term also 0, second term also 0. Now we are doing third term k into dou by dou x of x. So partial derivative of x is 1. Next here minus of minus plus. So dou by dou y of y square. So dou by dou y of y square is 2y. 2y into k here. So first two terms are 0. Finally I got here 1 plus 2y into k. 1 plus 2y into k. This is the value of curl f. This is the value of curl f. So that is only we mentioned here. Now we got the value of curl f. So we need to know about the n. Then we can do the dot product to integrate. Here one more important point we should know. So after calculating the curl f value, after knowing the n value, we should know about the surface. That means here about the ds and what are the limits of these x and y. So how we can get those limits? So here they given data, that data they given the plane and cylinder here. So we are going to use these two to get the limits. So here the surface S is ellipse region. Here we got here this surface S is, we got ellipse region. And in the plane, what is this plane? This plane is y plus z equal to 2. Y plus z equal to 2. This is bounded by the curve. What is this curve? And drawing the region of the S above the xy plane, we are taking here, that is x square plus y square less than or equal to 1. So here that means we are going to take here x square plus y square equal to 1, already taken here. So these two values we know. So first of all, integral over C, according to the statement, integral over C f bar dot dr bar equal to double integral over S curl f bar dot ds. Yes, this is the statement of the Stokes theorem. So already we calculated this value, that is curl f bar value is, we got 1 plus 2y into k. And here we are going to take the plane. What is that plane? XY plane. So what is the XY plane means? What is the n value? N value is k. So now curl f bar dot n bar value is 1 plus 2y into k dot k. So k dot k is 1. So 1 plus 2y. So finally this value is 1 plus 2y. Curl f bar dot n bar value is 1 plus 2y. So here we are taking dA or ds. See ds. So which one we are going to take here? Because here I am going to use the polar coordinates. Why? Because I am having the x square plus y square equal to 1. This is the circle. So I can use polar coordinates to calculate or to simplify the equation very easily. If I take Cartesian also I can do. But if you are using polar coordinate, that will be easy for us. We can get the answer in 1 or 2 steps. If you are taking Cartesian, it's a little bit lengthy compared to the polar coordinates. So that's why I am considering here solve this integral by using the polar coordinates. So what are the polar coordinates? X equal to r cos theta and y equal to r sin theta and ds or dA equal to r dr d theta. These are the polar coordinates. So here I need only y value and dA value. So y equal to r sin theta and dA equal to r dr d theta. So what about the r limits and theta limits? What about the r limits and theta limits? So here they given the circle is x square plus y square equal to, that means x square plus y square equal to r square. So what is the r value now? R square equal to 1 means r equal to 1. So radius is 1. So radius is starting from 0 to 1. How I got these limits? From the given circle. Okay. So x square plus y square equal to 1. Now the limits of the r is starting from 0 and here 1. So now I am taking the theta limits. How I can take the theta limits? So in the circle I am going to consider the complete circle. Complete circle means this is 360 degrees. So I can write this one as a 2 pi. So theta limits are 0 to 2 pi and r limits are 0 to 1. So now I can calculate or I can solve this integral by using the r and theta limits. Now I am writing here double integral over s 1 plus 2a into dA. So theta limits are 0 to 2 pi and r limits are 0 to 1. So here I am going to substitute the values in place of x and y and dA. So here 1 plus 2y, that means 1 plus 2y. So what is the y value? R sin theta. What is the y value? R sin theta. I am replacing here R sin theta. What is the dA value? dA value is R dr d theta. R dr d theta. Now I am going to simplify this one. So here integral 0 to 2 pi, integral 0 to 1. So 1 plus 2r sin theta r dr d theta. R dr d theta. So integral here, first I will do with respect to r, after then with respect to theta. So integral 0 to 2 pi. So 1 into r is r. So r dr plus 2 sin theta is the constant. Already r is there here. One more r. R into r is r square. So here integral 0 to 1 Here integral 0 to 1. Here dr, this is r square, dr and d theta and d theta. Now I am doing the integration here, integral 0 to 2 pi, integral r is r square by 2, limits are 0 to 1, plus 2 sin theta is the constant, integral r square is r cube by 3, limits are 0 to 1 into d theta. Now I am substituting the limits here, integral 0 to 2 pi, here r square by 2, that means 1 by 2, 1 by 2 is the constant here, plus and 2 sin theta 1 by 3 into d theta, that is only we got here. Now we are going to simplify the theta limits also. So 1 by 2 is the constant, integral 0 to 2 pi d theta plus 2 by 3 is the constant, integral 0 to 2 pi sin theta d theta. Now here 1 by 2, integral d theta is theta, limits are 0 to 2 pi, plus 2 by 3 is the constant, integral sin theta. What is the integral sin theta? Minus cos theta, limits are 0 to 2 pi. Now we are going to substitute the limits, 1 by 2 into 2 pi. 2 pi minus 0 is 2 pi, plus 2 by 3 into minus cos 2 pi, here minus of minus plus cos 0. So cos n pi is here, the value sin 0. Here this is cos 0. Cos 0 is 1. I am going to simplify here, 1 by 2 into 2 pi plus 2 by 3 into here minus cos 2 pi. So here cos n pi is, what is the cos n pi value? Minus 1 whole power n. So what about the cos 2 pi value? Cos 2 pi equal to minus 1 whole square, that means plus 1. So minus cos 2 pi means here minus 1 plus cos 0 is 1. So finally this term is 0. Here I got, this will be 0. So finally 1 by 2 into 2 pi. So 2 will be cancelled. I got 5. So here this is the value of double integral over S 1 plus 2y into dA value. What is the value I got here? Pi. That means integral over C f bar dot dr bar is equal to pi. So here if they are asking me to calculate the line integral, we can calculate by using the surface integral also when you are using the Stokes theorem. We'll see one more example here. So here they mentioned using Stokes theorem, calculate double integral over S curly f bar ds, and which is f value they given xz I plus yzj plus xyk here, and S is a part of the sphere. What is that sphere? X square plus y square plus z square equal to 4, that lies inside a cylinder with a base x square plus y square equal to 1 at the top of the plane xy. So here I am taking the space curve C. So what is that? We can observe here in the space curve C. This is the total curve, and we can solve this one, x square plus y square plus z square equal to 4. At the same time, we can take that the value is by using the x square plus y square equal to 1. So when you are solving these two equations I am getting here, this will be cancelled. Finally z square equal to 3. So this value is z equal to root 3. So here C is the circle that determined by using the x square plus y square equal to 1 and z greater than 0. So here we are observing this curve. This is the circle. That is x square plus y square equal to 1, and here this is the total sphere. So what is the R value we are taking here to calculate the f bar dot r bar? So here R of t equal to x of t. Already we know this is R is xi plus yj plus zk. So x of t into I, y of t into j plus z of t into k. So here we are taking the parametric circle. that is x equal to r cos t, y equal to r sin t, and r value is equal to 0, because here we know the circle equation x square plus y square equal to 1, that is equal to r square. We are going to substitute these values here in the r of t. So r of t equal to cos t into I, that means x value. So xi plus yg, right? So cos of t and y is sin of t, and z value x equal to cos t, y equal to sin t, and z equal to root t. These three values we are substituting here for the r. So cos t plus sin tj plus root 3k. So when you are doing the r dash of t is nothing but dr by dt. So if derivative of cos t is minus sin t, so minus sin ti. Here derivative of sin t is cos t, so cos tj. This value is 0. So now we are going to find f of r of t. What is the f value here? xzi plus yzj plus xyk. So here f of r of t equal to cos t, sin t, and root 3. So what is that we are taking here? This is the x, y, and z. So root 3 cos ti, root 3 sin tj plus cos t. So we are going to calculate the double integral over s curl f dot ds equal to. We can calculate this one by using the line integral also. Integral over c f bar dot dr bar, f bar dot dr bar. So here, so integral 0 to 2 pi, we are taking the limit of the theta. So f of r of t dot r dash of t into dt. So integral 0 to t, what is the f of r of t value? Already we calculated, we are substituting here. Root 3 cos ti plus root 3 sin tj plus sin t cos tk dot, and already I know about the r dash of t. What is the r dash of t? Minus sin t into I plus cos t into j. Now we are doing the dot product here. I dot I is 1. So minus root 3 sin t cos t. And here root 3 and here 1. So root 3 sin t cos t. So here k dot k value is 0. Here we don't have the k value. So that's why we got 0 here. Only we got the I and j coefficient. So here root 3 sin t cos t and root 3 sin t cos t, these two will be cancelled. We have here minus, here plus is there. So this is the 0. So integral 0 to 2 pi 0 dot dt value is 0. So finally curl f bar dot ds equal to 0. So if you calculate a line integral along the curve C also, we will get the same value. So this, if you know, use the parametric equations also, we can solve this. So this is the way we can calculate the given line integral or surface integral by using the Stokes theorem. I hope we got clear information about the Stokes theorem and how to solve the Stokes theorem problems. So if you want to do some more problems or some more examples, if you can take these references. So engineering mathematics textbook written by TKV Iyengar, and engineering mathematics textbook written by BS Gravel, and one more textbook also is there. You can use BV Ramana also. Okay, and you can use the some more Google links. So these Google links also you can use for your better clarity and information and more examples about this Stokes theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.